In a medical laboratory, you have 240 injections, one of which is for anesthesia for a rat. If anesthesia injection is injected in a rat, it will faint in exactly 24 hours. You have 5 rats available to determine which one injection contains the anesthesia. How do you achieve this in 48 hours? To simplify this puzzle, according to this puzzle, you have 5 rats and 240 injections. Any small dosage of anesthesia takes around 24 hours to be effective on a rat. Given the nature of anesthesia, effectiveness refers to its tendency to make the rat faint. Thus, any dosage of this anesthesia should make them faint in approximately 24 hours. As the rest of 239 injections shows no effect, how will you find that particular injection which has anesthesia in it using the 5 rats you have within a period of 48 hours, that is in 2 days? This is an interesting logical puzzle asked in several job interviews. Now take your time to arrive at a solution and continue to watch further once you are done. Let me explain the solution now. Let's start solving this by naming the rats as rat 1, rat 2, rat 3, rat 4 and rat 5. Our next step is to label each injection with a number. We are using 5-digit number with 0, 1 and 2 being the only digits in them. For example, our labels will look like 110000, 10221, 12011, etc. You may have the question, why 5 digits and why only 0, 1 and 2? This is because using 3 numbers 0, 1 and 2 as 5-digit numbers, we have 3 power 5 which is equal to 243 unique ways of arranging the numbers. As we are left with 240 injections, this would give us enough ways of labeling each of them. Here is the data which shows 243 possible arrangements, of which only 240 we are going to use. So far we have labeled them. Now what are we going to do with this? Each place in the 5-digit number corresponds to each rat. Let's take the injection 12210. Here the leftmost digit, that is 1, corresponds to rat 1 and the rightmost digit, that is 0, corresponds to rat 5. A rat that is assigned with the number 1 will be given that injection on day 1, that is at the start of the first 24 hours. Similarly, a rat that is assigned the number 2 will be given the injection on day 2, that is at the start of next 24 hours. And a rat which is assigned with the number 0 will not be given that injection at all. So to make this easier, consider an injection labeled 12210. Since the leftmost digit belongs to rat 1, a small dosage of this injection will be given to rat 1 on the first day. Second place corresponds to rat 2, so another small dosage of the same injection will be given to it on day 2 because we have the digit 2 in that place. Third place belongs to rat 3 and it will be injected on day 2. Fourth place belongs to rat 4 and it will be injected on day 1. Fifth place belongs to rat 5 and the corresponding digit being 0, rat 5 will not be given this injection on both days. Our rat 5 is so unlucky that it never gets to taste it. In a similar way, we inject each of those 240 injections by following the label instructions given on them. Here, I have made a list of injections received by each rat on both days. Have a quick glance at them if you are still confused with the labeling. Now that we have injected all this, how do we know which one is the anesthesia? Let's again take the injection label 12210 as an example. If 12210 was the only anesthesia, rat 1 and rat 4 which received its dosage on the start of day 1 should faint after 24 hours. Rat 2 and rat 3 which received its dosage at the start of day 2 should faint when the second day ends. Finally, rat 5 which never received this dosage will stay awake. This pattern of fainting will not be repeated in any other injection as all of them are labeled in a unique way to make the rats faint. Remember, if any of the rats fainted at the end of day 1 itself, it will not be given any further injections as it is already under the influence of anesthesia. So at the end of 48 hours, by observing the fainting pattern of rats, we can find the anesthesia by matching the pattern to the label provided on the injection. Apart from the method which I have explained now, there is another way of arriving at the solution. Split 240 injections among 5 rats and inject each of them with 48 unique dosages. Consecutive injections should be given at a regular interval of 30 minutes so that at the end of day 1, all the injection, that is 48 times 5, which is equal to 240, will be distributed among the rats. Timing should be noted while injecting each time. If any such rat was to faint, we can simply note the time at which it faints and trace back 24 hours to find the injection given at that time, which is our anesthesia. Unlike the previous method in which we observed a pattern of fainting, here we will observe only one rat getting fainted as the injection it received wouldn't have been injected to any other rats. The issue with using the second method is that the consecutive injection interval of 30 minutes is too small to trace back to the right injection as we can't be sure whether the effect of the drug was delayed. Of course, this method is simpler but works only when we can assure that the drug would show its effect in exactly 24 hours. Hence, it is better to go with the first method. That's all for this video. Let me know if you have any questions. I will try to address as soon as possible. Thanks for watching. Let's meet in the next video with one more interesting puzzle. Thank you.